Hello, this is my workspace here, and we already have two values, but let's calculate the rest of the critical values. So for the axis of symmetry, we just take the x value of the vertex. So we get x equals 67 quarters, which is this one right over here. Okay, so now for the function, I'm going to start off with intercept form because we already have both roots. So it's y equals a, and then x minus the opposite of the x value here, and the roots, minus 35, and then x plus 3.5. And now we have this missing a value, which tells us how steep the parabola is, and as well as if it faces up or down. So to solve for that, we can just plug in a point. And we have the vertex, so I'm going to plug in the vertex. So we're going to say 24 equals a, and then the x value, which is 67 quarters, minus 35, 67 quarters plus 3.5. And now I'm going to quickly solve. Alright, so I know this a value looks pretty ugly, but that is indeed the a value. So now I'm going to plug that back into our equation up here, drag this down, and we get y equals negative 384 over 5329 x minus 35. Just going to make some room here, erase some of this stuff. X minus 35, x plus 3.5. And this is our equation in intercept form. So let me quickly do some cleaning up, and then I'll be right back. Alright, so now we have the intercept form, and we can convert this into standard and vertex form. So let's start off with standard form. It's pretty easy, you just need to multiply them all out. I think this serves as a good reminder about how nature and reality itself is just so complicated, and the everyday things you do in life. Just if you look at the underlying math that goes on, it's just crazy. I'm just even grateful for that, for the complexity of math and how it just all works. Okay, this right here is our standard form equation. Now it's time to find the vertex form. So the vertex, finding the vertex form isn't too hard since we already have the a value. So vertex form usually is y, the general equation, a, which is the slope, which we already have, x minus h squared plus k. Now, we already have a, so we could just plug in our values. Negative 384 over 5329 x minus, and we have the vertex here. So h is just going to be the x value of the vertex up here. So 67 over 4 squared plus, and then the y value for the vertex up here. So that's going to be 24. Okay, and this is our vertex form. Now we find the y-intercept, which is not too hard because we already have the equation. So I'm just going to take standard form here. It seems the easiest. And we just plug in 0. So we'll say y equals negative 3. But this whole thing, when we plug in x as 0, the first two terms just multiply out to be 0. So we could just cancel that out. So already we have the answer. It's just that lone term on the end, the c term, 5329. And so our intercept, the x value is going to be 0. And when x is 0, y is 20,160 over 5329. And this point right here is the y-intercept.
So, needless to say, I did not expect the numbers to look like this, but I'm glad they do, because you might ask me, gee, why didn't Joel pick simpler numbers? And my answer is, I don't want to shield myself from the complexity of reality.
All right, I'm so excited to test this out. I'm not sure if it works, but we're about to find out. So I'm going to use Desmos to have our graph. Y equals, let's just do a standard form first. Oh, wow, look at this. That's the curve of my ball that I threw. So, all right, let's check the roots first. So the roots, I wrote negative 3.5, 0. And they have negative 1.50. That is correct. And 35, 0. Yes, there we go. All right, and now for the vertex. Fingers crossed. So 67 fourths, by the way, which I wrote, is the same thing as 16.75, I believe. So, oh, look, 16.75, 24. That's great. And now the y-intercept, which I can't believe this 20,160 over 5329 is the simplest form. It's crazy. So let me just calculate real quick. If that is indeed the right answer, 5329. So we have 3.783 here, and we have 3.783. So I did correctly do the y-intercept as well. And let's also to check if all the equations are the same, standard, intercept, and vertex, we can just do multiple lines. And if they all line up, then that means that they are equivalent. So I'm just going to do that quickly. There we go. The intercept form is the same as the standard form. And there we go. The vertex form is the same thing as all the other forms. So that means I correctly did everything. This is just beautiful, these numbers right here. I can't believe it. I threw a ball and I got these numbers for the graph. And I guess every time I play touch ball or football or volleyball, I will never look at the arc when I throw a ball up the same anymore.